Welcome to Pavuk Screencast 3. In Screencast 1, we used the Pavuk environment to build a very simple database application in under 5 minutes. In Screencast 2, we went into some detail about Pavuk objects. In this episode, we will explore Pavuk schemas using our home inventory as an example. We will also use our home inventory form to conduct ad hoc queries of our inventory table. Here we have our inventory schema. Let's briefly examine the columns. The field column is a position within the multi-value database. The delta column shows the number of changes made to a row since the record was last saved. The delta is not part of saved data. The object column is where we define what type of data is contained in the field. It's a drop-down list of Pavuk objects. Each object has a default label and a default size. To customize the field, we will enter the override values in this form. To be used by Pavuk, a field must have a defined object, and it is perfectly acceptable if fields empty for future use. The size column controls the size of the field, and it's defined in characters. The label column is where a useful label is entered. It appears on forms for input and as the header in queries. Multi-value tables always have a primary key that is separate from the field data. Alternate key indices are specified here. Setting the index to yes enables an alternate key index to be created. Setting the index value to no deletes an index and removes it. Setting the index to hard dupe or hard duplicate will cause Pavuk to return an error if a user attempts to enter a duplicate record. Setting the index to soft dupe or soft duplicate will cause Pavuk to return a warning if the user attempts to enter a duplicate record, but it will not prevent the entry. The required column is where we indicate which fields must be required. Pavuk will enforce the requirement on user input. The association column is where multiple fields are given a name to associate them together. This is commonly used in multi-value databases when we have nested relationships. The CD column works with the association column to indicate which field is controlling of an associated group and which are dependent. The sequence column is used to form a description dictionary for the table. By default, field 1 is used for a description. Entering a number in the sequence will override the default behavior. Entering numbers on multiple fields will cause Pavuk to concatenate the results into the record description. The pivot table is where other tables are specified to populate a given object. The SQL column identifier is used to identify fields in SQL stores. We will explore this in great detail in a future screencast. So let's now look at the list of objects in our inventory table. We have a text field, a date field that will produce a calendar control, a dollars field that will process input for US dollars, a file upload field, a select field, and we have some radio controls. Please note here the select field for the manufacturer is a pivot and is automatically loaded from our manufacturer's table at runtime. The file field is a special type of object in Pavuk. We do not store binary attachments as blobs inside the main database table. They're stored as linked attachments within the Unix file system. Pavuk will maintain all of the link controls for your attachment files. Now let's return to our inventory application. Here at the main menu, you may have noticed that we have another application called Manufacturers. It's a very simple application. It's the maintenance of the manufacturer table that we saw inside the schema. We can do a quick search on this table. It's very simple. It just contains a description of the manufacturer name and a manufacturer record locator number. In Pavuk, input forms are also used as search forms for the most common searches, and to enable people to find records quickly and easily. We can find all of the records in our inventory that are items tagged for my ham radio station by clicking the ham radio use and clicking the search command. The system will go and give us the record locator, the description, and it will return the use. We could further go and say we wanted a class of electronics and click search, and again the system will go and construct a query to return just those items. Users do not have to learn complex query syntax in order to return records from the data store. Now we'll reset the record, and we're going to pull up a record from the manufacturer of Kenwood. And we will search that, and let's pull up the HF transceiver. This record happens to show the multi-value capability that's within the multi-value data stores. We have options, which is one field, but it has multi-values or subfields that are integers of 1, 2, 3, and 4. We can have multiple occurrences of option values contained within the same field. All option values are treated independently and equally for search. This is a very powerful construct, and we'll discuss it later. So there you have it. We've gone and improved our schema by adding more fields, and we've updated our inventory form to have more fields. Stay tuned for Screencast 4. Thank you.